All right, on to the back of the worksheet. This is number 6, and we are looking at a plant cell with a solute potential of negative 7.5 bars, keeps a constant volume when immersed in an open beaker solution that has a solute potential of negative 4 bars. Identify, so letter A, identify what type of solution the cell was placed in if there is no change in volume or mass. So if you have no change in volume or mass, that means you have no net movement of water into the cell, you have no net movement of water out of the cell, so that is an isotonic solution. Okay, and so that's when you have the water potentials being equal on both sides of the cell, which leads us to letter B. What's true about the water potential in the solution and the cell in this type of solution? The water potential is going to be equal. Inside the cell and outside the cell. Okay, and so you're not going to have a net movement of water in any one direction. It's just going to, make the cell stay the same size. It's not going to get bigger. It's not going to get smaller. Okay, so the next one is letter C. We're going to calculate the cell's pressure potential. Give your answer to 1 decimal place. All right, so this brings us back to our formula. All right, and so if you remember, we have water potential equals pressure potential plus solute potential. Okay. And so we want to figure out what the cell's pressure potential is. So we're going to have to solve for pressure potential, okay? And so what we're going to do is we're going to subtract, we're basically just doing a little algebra here. We're going to subtract the solute potential on this side, subtract the solute potential on that side, okay? And so we're going to end up with our pressure potential being equal to our water potential minus our solute potential. Okay, so that's basically this minus this, and that's going to equal our pressure potential. Okay. And this is our pressure potential. I forgot to put the P there. Okay. All right, so now we just need to plug in our water potential here and our solute potential here. Okay, so we have our solute potential. All right, that is going to be, in the cell, it's going to be negative 7.5 bars, but we don't have our water potential yet. All right, we need to figure out what is that water potential. Okay, so one thing to note is this is an isotonic solution, and so the water potential inside the cell is going to be the same as the water potential outside the cell. Okay, so if we can figure out the water potential outside the cell, then we have our inside as well. And we can, okay, because outside the cell, remember, this is going to be in an open beaker solution, which means there's no pressure potential, which means our water potential is going to be the same as the solute potential, okay? So if we're looking at the water potential outside the cell, okay, that is going to still equal our pressure potential plus our solute potential, all right? But since that pressure potential is going to be 0, that water potential outside the cell is just going to be equal to our solute potential outside the cell. And what is that solute potential outside of the cell? Okay, that is going to be our negative 4 bars. Okay, so our water potential equals negative 4 bars. All right, and remember, in our setup, we are putting a cell into that beaker of solution. We have negative 4 bars outside. And since it's an isotonic solution, we have to have negative 4 bars inside. And so that is going to be our water potential that we're going to use in this equation over here, okay? And so now we have our water potential over here, and we have our solute potential, which was up here, and we can solve for our pressure potential, okay? So our pressure potential is going to equal -4 bars minus, remember we solved for this pressure potential, we ended up with this equation. So we're going to subtract our solute potential, with that solute potential inside that cell is -7.5 bars. Okay, and if we know math, -4 bars, what's minus a negative? That's going to be a plus. So we basically have -4 plus 7.5. Okay, what is that going to give us? That is going to give us a positive 3.5 bars. Okay, and this is our pressure potential. I keep forgetting to put the P's on here. Okay, that's our pressure potential. Okay, so our pressure potential of inside that cell equals 3.5 bars. Okay, and that is our answer.